Ladies and gentlemen, hello and welcome, coming again to you not quite live from One Take Studios. Today also known as my dining room table. There we go. Today's topic is linear regressions. And linear regressions, the idea of a best fitting line is what we're working with here, but we're trying to be a little bit more exact. We could just take my improvisational ruler here and say, all right, well, what line best fits these points? Remember that if we're talking about a set of data, we want the line that best fits the pattern of the data. So if we look at this, we can see a slight increase. So we're looking for a positive relationship here. And I would like my line, if it's truly the best fitting line, to be as close to as many of these dots as possible, kind of running down the middle, again, while modeling the data and what it appears to be doing. So let's say, for the fun of it, I think that my best fitting line might be right about here or so. I mean, I got 2 dots on top, 2 dots on the bottom. This one's just a little bit above, so that looks pretty good, right? Yeah, but how do I know? How do I know it's accurate? I mean, I eyeballed it, I guessed. Good thing for us, there is something called the least squares method for finding a line that really is the best fitting line. The concept is something like this. It says, all right, I'm going to take every single data point that I have and I'm going to bring that data point to the line. And then I'm going to make a square. Wow, that is a hideous square. Let's fix that. I'm going to make a square to show the relationship between that data point and the line that I think might work. So there we go. There's another one. We'll make a square out of it. So whatever that distance is vertically here between the point and the line, we're turning that into a square. Turning that one into a square. That's going to be about right there. Okay, so aside from making this really weird looking, what have I done? Ooh, little tiny square. Little tiny square. There we go. Well, I'd like you to think about something. All right, what happens now if I move the line? What happens if I take this little end here of the line and I just nudge it upwards? What happens to this square? It would get smaller, yes? But if I nudge this end up, that'll nudge this end down probably a little bit. If I'm thinking about like a rotation sort of movement, what's going to happen to this square? As the line moves away from it, this square is going to get bigger. What if I just, like translation, what if I just slide the whole line up? Because if I slide the whole line up, I can make this square smaller, but then these 2 squares would both be larger. What the least squares method does, it says, all right, let me take the areas for each of these squares, and I'm going to add them all together. And then what I'm going to do is I'm going to play with this line, and I'm going to keep adjusting it until I can get the smallest total area possible. Because if I can get the smallest total area of all of my squares, that means I will be as close to all of the dots, as close to all the data points as I possibly can get. Now, can I do this myself? No, not really, and especially not well. So, it is a very good thing that we have our calculators with us today. These are the data points right here that I used: -4, -2, -1, -3, 3, -1, 4, 2, and 8, 3. So if we assume those are our data points, let's switch over and take a look at the calculator, shall we? From our calculator screen, we would like to open up a brand new document. So that is option number 1 here, brand new document, and click. It asks us very nicely what kind of document we would like. We're going to go with something called lists and spreadsheet, because right now we have a bunch of information. We've got our ordered pairs, and we'd like to put those in place. So our first ordered pair was -4. I'm going to slide over here, -4, -2. Okay. Next one up was -1, and that was paired with -3. And then we had 3 paired with -1, 4, and 2. And then last but not least, 8 and 3. Now these are all XY ordered pairs, so let's tell the calculator that these are XY ordered pairs. So at the very, very top of the column of all of the Y's, so here's all my Y values, I'm going to put the letter Y. Notice where I am at the very top, not in this line that says equals, we want to stay out of there. Let's drop back down and over, and all of these are my X's, so I'm going to put an X at the very top of this column. Great, I have a bunch of X's and Y's. Well, if I want the calculator to do something for me, I should probably ask nicely, and we say that everything fun and exciting is in the menu, so let's go to menu. We are currently actually working with some statistics, and we would like the calculator to do some calculations for us. Ooh, look at all of my options. In fact, hey, linear regression, mx plus b, that looks familiar. Let's check that out. Ooh, that's kind of scary. What does that say? Well, it wants to know where the x's are, and quite frankly, they are in column A. If you're familiar with spreadsheets, this works a lot like a spreadsheet, but you know what? I can just say, hey, the x's are where I told you the x's are. Where are the y's? Well, all the y values are where I told you the y values are, so great, there we go. And okay. Will it let me hit okay from there? No, it will not. There we go, that's better. All right, ooh. Well, what on the heck is that? We have a whole bunch of stuff going on here. Ooh, we do see the words linear regression, which is the title of the regression we just ran. We have the equation mx plus b, which is what they said we were going to have, so I suppose that's a good sign. Let's see here. We've got, what are these? Oh wait, that's m. That's b. Hey, they just gave us the equation for the best fitting line. Y equals 0.488 times x plus negative 1.17. Interesting. Very interesting. You know what? I'm going to take a moment and I'm going to write that down in my paper. What was that again? Ooh, I got to go back and check because I already forgot my numbers. Let's see here. 0.488 was my slope, so 0.488, that's going to be this guy. So y equals 0.488x, so mx plus b. There was actually a negative number, so I'm going to put a minus there. And again, going back to look at it real quick, like here, we've got that was a 1.1767. How accurate do I want to be? Well, there's no real written rule here. I'm going to go with, let's go with 2 decimal places. So if I round that correctly, that's negative 1.18. Negative 1.18. So, again, I'm jotting that down. Negative 1.18. I'm going to go here to make that happen. Nope, I'm going to go here. Negative 1.18. This equation, this is the equation of the line that truly does fit through all of these well. Huh, how did I do? My y-intercept negative 1.18? That's not a tragedy. A slope of about 1/2. Up 1 over... Hey, I actually did a pretty good job with my line. I'm sort of proud of myself right now. But this is going to be a really accurate representation of what this data is doing. Want to see something fun and exciting? Go back to your calculator for a second. Check this out. All right, so if we go back to the calculator, a couple of things. One, if you continue scrolling down this, there's an r squared number, and there's an r number, and there's a residual number, and we're just going to look at this r value for a moment here. Something that I'd like to bring up. This says that for this particular regression, there's my brain for a second, regression, it has an r value of 0.8748. What does this mean? Ladies and gentlemen, this number is positive, therefore this is a positive regression. And we said that the line does go up, so that's completely, that makes a ton of sense. So positive number, the line went up. The closer this number is to 1, the more perfect the regression is. So in other words, the closer this is to 1, that means that the closer all of my data points are to truly being in a line. If all of my data points were in an exact line, this would say 1. Well, what if my r value here was negative 1? Well, if it's negative 1, that means that we would have a negative correlation, a negative slope. The line would go down instead of up. But again, if it was negative 1, that would mean it's a perfect line. So the closer you are to 1 or negative 1, the closer you are to having a perfect line with your data. So what would that mean if my r value was 0? If my r value is 0, that's as far as we can get to being away from both 1 and -1 at the same time. What does this mean? It means that there isn't really much of a relationship. So the closer we are to 0, this is telling us, hey, I can give you an equation, but man, it's kind of meaningless. 0.87, that's a decent number. All right, if we go with 0.87, we're like, that's pretty close to 1. I have a decent relationship here between my variables. And that's a good thing to be able to study. All right, something else fun and exciting. Let's go back to, do you see where it says add a page right here? We're going to go Control, Document to add a page to our document. And this time we're going to go with, where'd it go, not that one, adding data and statistics. Well, those are not my points. What am I going to do with those? Click to add variable. What would I like to see here? I would like to see my x's on my x-axis. Ooh, look at, they moved all by themselves. And if I go here on my y-axis, I would like to see my y's. That looks a heck of a lot more like the graph that we just had. All right, so now again, where is everything fun and exciting? On the menu, what would we like to do? Well, we would, I don't know, kind of like to analyze what we have here. Ooh, look what's on the analyzation menu. Regressions, and again, mx plus b. Check it out, check it out. I'm going to move this guy out of the way because you can do that too. But that is what the perfect line would look like based on the scale that they've got set up here. And you can see it goes right down the middle of those dots, and it gives us the equation. What does this screen not do? It does not give us the R value. So we actually have to be over on this page right here if we're going to get the R value to find out how good our relationship is. But we can actually see it on this page right here. So fun and exciting stuff. Ladies and gentlemen, ideally, these would all ultimately have some meaning to them. And we're going to see that hopefully coming up in future examples of things. But this then gives us the projection of our line and what might happen. So that means that somewhere down the line here, maybe like if x was 10 or 12 or 20, I could use this to predict what my y value might be based on the relationship of my current data. All right. I'll see you guys again soon. Enjoy playing with this.